Hello everyone. In this video we are going to learn Autopsy, digital forensics tool. Autopsy is a graphical interface to command line digital investigation analysis tools in the sleuth case. Now we'll learn how to run Autopsy. We open the terminal and tap Man Autopsy. There's some description of Autopsy. It shows when started the program will display a URL to paste into a HTML browser. And there is a requirement. The Autopsy forensic browser requires the sleuth keys. This software is distributed under the GNU public license and the author is Brian Carrier. Now I'll show the Autopsy arguments. This argument allows us to change the default setting. We can specify the evidence local directory, specify information for live analysis, or specify the server port. For example, we can change the default server port like this. Please make sure don't use the port number from 1 to 1024 because these ports are being used by other services. Now it shows the Autopsy is running and the local port is changed to be 1234, and this is the URL we copied. Please make sure don't use Ctrl+C because it will access the Autopsy. I open the browser and then paste it. We came in the Autopsy main page. There are three options: open case, new case, help option. And this website is official website of Autopsy. There contains a lot of information about Autopsy. You can learn it later. And the help option has the help files for using Autopsy. Autopsy organizes images based on the keys and hosts that they came from. A case contains one or more hosts. A host can contain one or more images. So firstly, we need to create a new case. Enter the case name. The case name must be valid directory name. So there's no spaces, no symbols. And the description of the case. And the investigator name. The investigator name will be used for the audit log. Now the case is creating. This is the case directory, and now we need to create a host for this case. Host name. And description of the host. And we can specify the time zone and the time scale. The clock skew is how many seconds the system was off from a synchronized clock, and the other we can let it block. And then the host is creating. We need to import an image file for this host. Add image file, and we need to get the path of this image file. This is the image file we want to import it. And we copy the location. And we need to select the type of image file. The difference between disk and partition is a disk drive is a physical data storage device, so it can be divided into logical sections called partition. Our image file is partition, so we choose partition. And then we choose the import method. Our image file can be imported from its current location using a symbolic link, by copying it, or by moving it. Now we can use copy it. Here is the image file details. Each host has a MD5 test file that contains the MD5 value for files that in that directory. Autopsy uses that file to validate the integrity of files. So we can choose to ignore the hash value for this image or calculate the hash value for this image, or we just can add the MD5 hash value for this image. Now we can choose calculate, and it shows the mount point and the file system type. Now we get the MD5 value, and then the image file is mounted. There are many options. Analyze the image file, or add a new image file, or close host. We can then close the host, close the keys, and return the main menu. And then we click the open key. It shows this is our new case. This is our host. The image file. Now we can use the image integrity to check whether the image file is modified or not. Click validate. Now it shows the original MD5 and the current MD5. And it shows path means it didn't be modified. Now we can analyze our image file.
Okay, guys, I believe you can already create a new case after part 1 tutorial. And now I'm gonna show you how to analyze the case using Autopsy. So you can see I have 3 different kind of cases here, and I'm gonna choose ext case. ext is the file system of Linux. So I'm gonna click OK and OK now. So let's do analyze. Now you can see the function of Autopsy has been shown you in this page. You can do file analyze and keyword searching as well. Also, you can sort the file by their types. And if you want to browsing what's going on in image, you can click image detail. Metadata allows you to analyze the image file by examining the metadata structure. But if you want to browsing files by block numbers, you can click data unit. Furthermore, if you have any questions, you can click help, and the instructions about Autopsy has been shown you here. So I'm gonna close that. Okay, let's go to file analyze now. File analyze allows you browsing the image file as file system and view the content of the files and directories. You can see there are different columns here, and the name of the file, the return date, and last access date, and last modified date. You can also view the size of the file and directory, the user ID and group ID of the file. And the metadata allows you to jump into that information by just clicking the links below. This column called type, it is a type of file and directory, and the in means a metadata structure. So I'm gonna sort by in. You can see D means a directory and R means a readable file. If this column has been checked, it means the file has been deleted. All the deleted file will show in red. And now, in left sector of this page, there are different buttons, different functions of it. This is the expand directories. And now the whole file system has been shown here. So you can see the main directory has etc, and etc include downloads. You can also click the links and it will jump into that directory. Another function is directory seek. So I'm gonna type something here. Now you can see my file system has jumped into main etc, and all the files has been shown here. Delete that. And also you can search the file by their names. So let me just ht password. Now ht password is here. What if I search something didn't exist? Okay, nothing gonna find. Also, you can search the files by their type, such as .pcap, and you know this is a file which using Wireshark and TCP jump. You can also search another files such as .doc. And also this button will show you all the delete files and just the delete files. So this one has been reallocated and this one has been deleted. And the difference between reallocated and deleted is reallocated didn't exist inode and you cannot jump into that metadata. but deleted, it will save the metadata about this file, and it means you can recover it. Now you see, if I click here, the information of this file has been shown below. And I can view it by ask to strings and hex, or ask to also export it. Okay, I will show you the information of the files by searching another called readme, and click that. So you can see now the content of the file has been displayed here. You can also display it by hex, and the hex numbers and the strings. Also, you can display it by strings. So here is a function called report. If I do report, it will generate a page. If you find something interesting, you can just report it and save as a txt file. And all the information about this forensic has been saved. Also, I can do export here. This will export these files in your system. So just follow the instruct, save. Okay, I'm not gonna do that because if I do that, my computer will freeze for nearly 5 minutes. So just choose the directory you want to save. And if you find something interesting in this file and you want to check it later, you can use this add note for this file. I'm gonna type something here. This is readme as secret, and click OK. Oh well, this node has been successfully created, and now we can view nodes. This is the node I have created before, and this is the node I have just created. You can browse this file using the directory, and also the metadata of this file is 1929. Okay, I'm gonna close that. So not only you can add node for the file, you can add node for directory too. Typically, if you have inode for this file or directory, you can create the node for that. Just click that. And there is another function called generate MD5 hash value. And this value is used for check the integrity of the file or directory. So let's go over the next function of Autopsy, which is keyword search. The keyword search, you can search an image file using grep for a given string or regular expression. This is totally different with file name search or directory search. This result will be a list of data units which have the string. Also, each data unit can be selected to view the content. You can see, you can search by ASCII or by Unicode. You can check that. And I'm gonna type something secret and click search. Now the result has been shown here. There are totally 55 results, and you can view the result by hex or by ASCII strings. If you drag down this block, you can view the block information and which inode it belongs. But this one is not allocated fragment, so I'm gonna find another one. Okay, this one is allocated fragment, and if you click here, it will show you the inode number. And also I can go over this inode information. You can see below. And let's just go back. By the way, you can also view the hex and view the ASCII string of this fragment. Okay, let's do a new search now. And you can see there is a checkbox called case insensitive, and I'm gonna show you this function. I will type in capital secret and do search. There is 0 hit about capital, but if I check this box and do it again, okay, the same result with lowercase secret. So another powerful function of keyword search is regular expression, and you can find the instruction of regular expression here. You can see the escaped values is these operations, and there are some examples here. Okay, let's just go back. Now I will use another case for regular expression keyword search, which is a NTFS case. NTFS is a file system of Windows, and OK, and click Analyze. Now I'm gonna search r-unalloc here. You can see there are 3 different hits. And do a new search again. I'm gonna use star escape some value. If I not check this box and do the search, it will show you nothing. But if I check this box and use star to escape value, it will be effective. So you can see there are 4 different hits here, and I can view it by hex or by ASCII string. The r-unlock is here. And you know, NTFS and ext is different type of file systems, and the metadata and data unit between them is different too. If you want to know something about that, you can go to Wikipedia or something other file system introductions. Autopsy also allows you to sort the file in your image based on their file type. For example, all executable file would be identified. So, if I click sort file by type, and you can see there are different checkboxes. Do not save data about unknown file type and something else. You can check this as you wish. Click OK. Now the result has been shown here. There are totally 37 files, and 10 has been skipped, and 27 has been categorized. And you can see 1 image, 1 executable, and 5 unknown files. Now I'm gonna show you another function called image detail. In image detail, it will list the details about the file or volume system, and the output of these more depend on the file systems. For example, this is NTFS, and you can see metadata information, first cluster, and the cluster size in content information. So what about ext files image detail? Let's do it. I'm gonna open ext case and go to image detail. You can see the file system type is ext2 and the last mounted at this place. Operating system is Linux. And metadata information inode range and blocks range, and in block group information there are different kind of groups, group 0, group 1, and each group contains this inode, contains these blocks. So you can also check FAT file system information if you want. Well, let's go over the most powerful functions of Autopsy, which are metadata and data unit. Especially when you combine these two functions together, it will be more useful. And I'm gonna show these functions using ext2 file system, which has been used by Linux. In ext2 file systems, the metadata is known as inode, you can see here, and the data unit is fragment, which is typically can see block. And I'm gonna search some inode. Just type in 10 and click view. It will show you this inode information. And if I click allocation list, all the inode will be shown here, and whether it is allocated or it is free. Go inode 2. You can see the file directory of this inode, and the file type is data, and 2 size is 1K, and inode times is shown here. Also, you can go to the blocks of this inode content. It will jump into data unit, and fragment number is here, and you can also display it whether in hex or in ASCII2 string. If you drag down this, you can also check the status. And if you click this pointer, it will go back to metadata 2. In metadata function, it will also allows you report or view content of this inode. So if I click here, you can see a display as ASCII2 string or hex. And also you can export content, the same thing, and add note for this inode. So how about the freed inode? The freed inode is something deleted, and it will shown as not allocated inode. However, it also includes direct blocks and indirect blocks. Maybe both of them, maybe one of them. Okay, now let's check data unit functions. You can see in the right side of this web page, there are different kind of buttons here. And if I click allocation list, it will show you all the fragment in your file system. Also, if you want to search a certain fragment, you can just type in here and specify how many fragments you want to see. And now you can see here is 5 fragments, which start from 10. So in conclusion, if you use this function, well, you can save a lot of time for data forensic. I'm gonna show you a simple example. Okay, I'm gonna close that. And remember, do you remember the nodes we have created before? And here is the inode of these nodes, the secret file. And I copy that, go to analyze again, and just type in that inode and then click view. Now you can see view content. Okay, I believe I can close it now. And this is a simple example about metadata and data unit function of Autopsy based on ext2 file system. You can also try it in NTFS and FAT system. Well, guys, I believe you can do the basic data forensic by yourself. And we do have some interesting lab questions in our final report. Before you go over that, I suggest you watch the part 3 of this video tutorial. It will teach you how to create an image file.
Right, so now we're going to show you guys how we made the testing image to begin with. When we open up my computer, we can see there is already a USB flash drive over there, and this is what we're going to be using to create our testing image. And now we're going to start a partition software called gparted to make a ext3 partition using the unallocated space on my flash drive. After we launch gparted, it's going to show us the default hard drive, but we're going to the top right hand corner to select the flash drive instead. Now we can see that there are 35 megabytes of unallocated space on the flash drive. We can just right click on that and select new to create a new partition. You can see that it has a nice GUI where you can drag to size that partition. For now we're going to go with 15 megabytes because we don't want to make it too big. Now we're going to click that check button to apply the partition operation. Click apply, and there you have it. The software is running the partition right now. Right, now that it's done, we can see we have an ext3 partition created on the /dev/sdb5, and it is 15 megabytes in size. Okay, so now we're going to put the files we prepared earlier for the homework into this newly created ext3 partition. And then we're going to create a folder named etc in the newly created partition, and we're going to move the password and shadow file from Kali into this folder so that you guys can work on the password cracking homework later. Here we are creating a text file called new.txt, and we're giving it some content. But then we'll delete this file and create a new text file with the exact same name but with different content. Now we are creating a new file named test.autopsy with a single line of words as content, and then we will delete it to see if we can recover the content of it after deletion. So now that we have all the files ready, you can go ahead and use the dd command to create the test image of the etxt3 partition. And we're going to name that image test_autopsy.dd. And now that DD has finished, we have the image file coming up on the desktop on the left. So now we can start Autopsy and perform analysis on the image. As you can see in the command prompt, it shows us the URL to access the Autopsy GUI. Just hold down Control key and left click that link, and it is going to open iSuite's web browser and go to that link. Now that you're seeing the cute dog, you can just follow the instructions given in the video tutorial before and set up the case, host, images, and so on. Okay, so now we are finally at the file analysis page, and I'm going to check that the content in the password and shadow files in the etc folder are valid. And you guys can start working on the homework problems from there. Alright, good luck guys. This is the end of our video tutorial. Thanks for watching.